Let me see. Okay, it's being recorded now.
Yeah, I found a alternative solution to record it. So now it's
Okay.
recording. Yeah.
So thank you and welcome to this very special event. Special event, not because of that we are just here to give prizes, but because of the fact that in the last 1 year, we have been achieving many milestones leading to this particular day. It has been a journey which was an exploration on both the sides, on the sides of students, as well as mentors, as well as jurors. And I think right at the outset, I must thank Ganeshwaran for meeting me in Dehradun, having a discussion, and getting into this mode of starting Indian Young Faces tournament. I think it was a challenge to start it because it's a tournament which operates at a very, very different scale. This tournament engages students for almost whole of the year who is participating in it and attracts the best brains among the school students. The problems are open-ended. They are not, routine problems, multiple choice questions or something like that. But it is like playing a perfect role of how a physicist works in his explorations of the topic which he or she chooses to, explore, understand, and arrive at some conclusions. Hats off to Ganeshwaran that right from day one, that it was done completely online. Right from starting the zero level test through Google Classroom and overcoming the challenges in taking care of more than 1,000 students. It was a very, very big challenge. But I think INYPT needs inspirations like that of Ganeshwaran. And that is what will bring the change in the quality of things which INYPT does at the national level or at the international level. Then, it was joy to meet young minds. At every level, there was some kind of an incentive which was there. And for this, we had a very interesting friend who has been helping us in between a lot. You have seen Akshat in the picture today. And I think he is a very confident boy. You must have seen from his voice itself. And I think he was more than a mentor for this particular program. It was a lesson for me also that how young people can present themselves and think very clearly about problems of physics. One cannot imagine somebody talking about Lagrangians while studying in class 10 and 11. So that is the kind of personality which I found in Akshat. Akshat, thank you very much for making this program.
Pleasure is all mine, sir. Thank you very much.
Then I think I must also tell you that there were many people who came in between and helped us to do the things. I cannot really name everybody, but there were a number of people who were coming and helping us. And one of the best things which has happened is this also, that a complete record of this process was maintained on our website also. Any student can go there, check what has been happening during the year. It itself is a case study for us to follow and understand for creating quality programs. I wish if we can have in the next year's program a team around Ganeshwaran, because that is very much desired, because it is not that people who are helping us, they are free people. They have their own work. They are engaged in very many other activities also. Finding time for INYPT and especially for this Indian Young Physicists Tournament, we felt highly obliged for their time and dedication. So let me just begin with the announcement of the names of the winners in the grand finale. I think every milestone was like a finale. And believe me, whenever those students were, posting videos, and you sit down in front of those videos and start wondering how come they are really doing such an excellent work. Because the solutions of these problems were not available anywhere in the books. They were supposed to design things on their own, conduct experiment, take observations, present those things in a meaningful way, that what they have really found, give their conclusions, and not only that, compete with the other students also in a very, very competitive mode. It was not that they were just coming, making their presentation and going away. They were presenting, they were being asked questions by their competitors, and they had to face a jury also. To imagine, such a tough competition doesn't happen even in the defense of a PhD thesis. A person comes, the examiner is there, but here too there was a kind of a very, very structured involvement, not only of the candidate himself, but other candidates also. And there were some credits which were given for all these things when they did so. I think, to my mind, the best thing which has happened for this competition is this, that INYPT also, thought of going ahead with crowdfunding for giving the prizes to the worthy winners. We were estimating about 50,000 rupees as the expenditure, but our benefactors gave us almost double that amount. And I'm very glad that the first prize is being given in the name of Professor V.S. Murthy. He was the General Secretary of INYPT in late 90s. I had personally met him in one of the conventions. And I know that how humble and meticulous he was, and how much he was interested in thinking about, encouraging teachers, students from those areas from where it is very difficult to find that they will come and participate in our activities. He was in IIT Chennai, IIT Madras, we call it basically. And I am very happy to tell you, dear friends, that his daughter, Professor Madhurima, who is Professor of Physics at Central University of Karnataka, is with us. And her brother also, who is an IIT professor at IIT Bombay, Sai Murthy, they both, came together and they said, let us give some good money for the first prize. And when we realized that they both are the son and daughter of Professor V.S. Murthy, it was a pleasure for us to name this first prize as Professor V.S. Murthy trophy and gold medal. So let me now tell you who is the first prize winner. He is Bhanav NS. He is from Lesson Lens Integrated Campus at Changramukulam, Kerala. Am I right, Bhanav, in pronouncing it? And he gets a prize of, apart from the gold medal, 20,000 rupees. And I think that is worth celebrating and saying congratulations, Bhanav. You have done a great job. We watched your journey, and that journey was worth appreciating and enjoying. So this is regarding the first prize. Let me now come to the second prize. Second prize is silver medal with a cash prize of 10,000 rupees, and it goes to Chainika. I hope I am pronouncing it correctly. And Chainika is actually from Jaipur, and she studies in Kendriya Vidyalaya. Jaipur, I think, has got very interesting learning traditions also, Chainika, because Jaipur has one of the oldest observatories, and that shows that what kind of people must have lived there who thought of exploring the sky during night. Lately, when we had the convention at Jaipur last year, I made it a point to visit that observatory once again and saw each and every tantra which was there. That was a kind of a lesson to us also. So, Chainika, congratulations for this achievement. And
I request the winners to show the trophy and medal when you are called out. It would add some
okay,
life.
right. We will do that also.
And is the applause button not working, sir?
Uh,
The applause.
Actually, I will have to search, I am
No.
concentrating.
I have hyperlinked that applause after each winner's name in the
Okay.
document. I have hyperlinked the applause. If you just click it and click further, I think the applause will. Appreciation should be loud and.
Why don't we go old school, unmute and actually clap?
That would be good.
Actually,
It doesn't. That's also fine, but
Congratulations to all winners.
if you can do that, I don't think that I can do that right now.
Okay, let me see.
Because there is a advertisement coming before that, and that's what is getting mixed up.
Okay.
It is happening on the YouTube, so there is a problem. Right? But I think our applause is there for each of the participants.
Absolutely.
And don't worry about it.
Okay.
Our applause is always there. Don't worry. Right? Now I'm going to the bronze medalist. He gets a cash prize of 5,000 rupees, and his name is Pranav Tyagarajan. He is from Sri Krish International School, Tamil Nadu. Which place, Pranav?
I actually live in Nagar, but the school's a bit far away.
Okay.
It's in Kovur, actually.
Okay, all right. So these are the prizes which are there. Let me just show you the trophy. I will share the screen with you, right? And the medals also. Just wait for a minute and I will be back. I'm sharing the screen. Is there a screen sharing here? Yes, it is.
Now your medal is below the screen, like it's cut off from the view. Yeah, very good. Bana is doing
That's
a good
great.
job.
That's
Oh,
great.
yes.
That's great.
Pranav.
Bana is showing the trophy and medal.
Oh, yes, very good. Then I don't think I should share the things. Yes, Pranav, that's
Chanika
good.
is not showing the medal.
Chainika, can you also show the medal?
Pranav, you too, please.
Yes, Pranav, yes, very good. Oh, yeah.
Let's take a screenshot, shall we?
Oh, yeah. Yeah, all of
Hold
you
it in your
can-
hand, yes.
It's safe for a group photograph. Smile.
Now, what I would like to do is request each one of the winners to talk about their journey, and if they can really share their presentation which they made for the grand finale with us, I think that will be wonderful. So I will start with Chainika. Chainika, you please share the screen and then run the video and also share your experiences which you had in this particular competition.
What should I do?
Can you share the screen and play the video of the experiment which you worked on?
Sir,
So,
all the videos are
which
hyperlinked in
round?
the tournament website. So if you want, I can just play the video and
Yeah, please, you can do that. Yeah, do that.
yeah, I will share my screen also.
Yes, please.
Share screen. Share. All of you can see the website, right?
Yeah, we can. Yes.
Yeah, I just quickly open up Shanika's report.
Yes.
Right. Where did it go? Oh. Just a sec. Yeah.
Chainika, yes.
Reporter. Here I will have all the reporters. Shanika. Reporter who is being opposed. So reporter is answer about this. Reporter. Yeah, here. This is the one. Round 2 reporter, Bhana Chanika. Here it goes. It's a
Oh,
live
that's the complete
video,
report.
so we can just see for a few.
Hello everyone, in the INYPT 2024,
It's
we
a,
need to present the problem number 11, pumping straw. The problem statement is, the simple water pump can be made using a straw shaped into a triangle and cut open at the vertices. When such a triangle is partially immersed in water with one of its vertices,
is the
and
audio
moving it along
heard?
the vertical axis,
Yes,
the
yes.
through the straw. Investigate how the geometry and other relevant parameters affect the pumping speed. This is the visualization of the problem statement. The above vertex are the secondary vertex and the lower vertex is the primary vertex. These are the side lengths A, B, and C, and this depth is D2 and this depth is D1. Throughout this presentation, I am going to talk about problem, demonstration, explanation, mathematical representation of the phenomena, graphical representation of data collected, prediction versus actual data, errors, and conclusion. The setup of the problem consists of the triangular pump. The rotation of the pump is done using a motor, and the pump is placed vertically into a bowl of water such that the primary vertex is exactly above the center of the base of the bowl. The setup looks like this. It has a pump, a motor, and a clamp stand. When the pump is in motion, it looks like this from the side, and if we can see carefully, we can see the water droplets coming out of it. When the pump is in motion, it creates a circular stream of water around it. The secondary vertex expel water out of them and it forms this. Why does this happen? It happens due to the centrifugal pseudo force that acts on the water columns when it is inside the straw pump. When the gravity and the atmospheric drag is not sufficient to balance this force, the water propels itself.
Excuse me, can I just ask one question regarding this?
You are asking something?
Yeah, just one quick question.
Hmm.
Chanika, actually, I was trying out the same experiment, and when I had that axis of rotation suspended from the motor, just like you have. I found that it starts spinning due to the centrifugal force. It starts spinning like a fan. So the whole setup itself I could not reproduce. Did you face such a problem when you tried?
Just
Yeah,
could you
Chainika?
repeat what problem you were facing in the setup?
What?
Please
Could you
repeat it.
Okay, 1 second. I'll just pause my. So we fixed this axis of the straw to the motor, right? And when the
Yes,
motor
sir.
rotates, the axis will rotate like this.
Yeah, yeah.
But the motor spins so fast that I found that this axis is going like this. And it's becoming
Yes,
like
sir.
a. So how do you prevent it? Because we need to make this axis along the vertical only. How to prevent this? How
So,
did
sir,
you do it?
what I did was that, sir, I don't know which motor you used, but like the motor that I used had a thick axis. So it just like the straw could fit into it. And then I just like plastered it with black tape and that was sufficient.
Okay, okay. Should I continue with the presentation? Sir, it's 11 minutes long.
I think we got a feeling of what was there
Yeah.
in this. And Chainika, thank you very much. You did all the things, and I think you answered the query also very nicely right now. Once again, congratulations. So can we now go to the second prize winner, Pranab's presentation?
Okay, 1 second.
Outward, and it causes the sprinkling effect by the pump. Let us
Yeah,
Pranav,
Pranab Tyagarajan.
Pranav Tyagarajan, and this is my solution report on the rigid ramp walker. I have decided to make my presentation in Prezi, an online website for making presentations, just like Microsoft PowerPoint. It isn't complicated to use Prezi, and all you have to do is just either press the space bar to move forward, the left and right arrow keys to move backward and forward respectively, or operate the presentation with the mouse, clicking on the arrow buttons on the lower part of the screen. I would suggest that you first watch the video where I will be taking you through the slides, and later you can look into the presentation by yourself. Prezi does not need any special software, and all you have to do is just click the link and dive into the presentation. The objective is to construct an object with 4 legs, such that it walks down the ramp. If you don't understand what walking means in context of the rigid ramp walker, that's okay. This is a slow motion clip of how the walker walks. People who chose this problem have to find out and prove what affects the terminal velocity of the walker. The assumption I have formed is that the terminal velocity is directly proportional to the angle of the incline. What indirectly is proportional to the terminal velocity are density, surface area, and friction of the ramp. The leg structure also plays a role in the movement of the walker. There are a few points of interest to be discussed with the rigid ramp walker, and it shall be done after this bonus slide. It may seem unorthodox to teach a couple concepts before the applications in a research paper, but I feel that it is important to do so, as it should be friendly to people who don't know the concepts but have an overall understanding of it and enjoy it. This may pique their interest to possibly learn more. This, however, is not exactly beneficial to those who know these concepts to a very deep level, but I suggest that you go along with it too. First up, torque. Torque is the rotational force applied to an object around its axis, causing it to rotate. It depends on the applied force and the distance from the axis of rotation. It's mathematically represented as torque, tau, is equal to force times lever arm, which is R. An example is, imagine turning a key in a lock. The force you use and how far you are from the keyhole That is the axis of the door.
Should I
The door.
move forward?
To turn the key close to the keyhole, you need more
Ah.
force. Turn it farther away and less force.
Sir, I think you should go to the lower latter part,
Okay.
so that we can get a feel of what was the discussion
Yeah.
regarding the result and
Yeah.
Using the concept, starting with the mechanism of the walker, it
maybe
goes
the last 2-3 minutes.
for the
Okay.
step function. An animal walking down a ramp with its hind feet performing a dragging action on the slope is a way to visualize the movement of the walker. An interesting point to note about the mechanism of the walking is that each leg needs flexibility to execute the step function. The rear leg serves as a support system, influencing the walker's speed. Having two rear legs enhances the stability, while having one just raises the likelihood of the walker tipping to a side. This important note, the height of the walker is measured from the bottommost part of one of the legs to the body. The breadth is measured from one front leg to the back leg, like anything with a rubber base toppling when applied with force on the top. The second case is a smooth slope. The walker slides without control, increasing the risk of falls due to the absence of a regulated movement. At a specific angle, the walker can be in motion, but it won't exhibit a true walking action. On smooth slopes, all four of the ramp walker's legs will maintain contact with the ground as it slides downward. The incline increases. The velocity also increases. Again, by the math, the walker must decrease in speed as the coefficient of friction increases. The same holds true when performed experimentally. The condition for toppling when mu is greater than b by h has also been tested experimentally, and it does topple when mu is greater than 4 by 3. Where small l is the length of the pendulum string and g is acceleration due to gravity, which is assumed to be constant, and alpha is the angle of the incline. Similarly, the time period of the legs of the walker would be t is equal to 2 pi times square root over L dash by cos alpha g. The value of capital L dash would be some. If the time period of one leg is t by 2, directly proportional to the velocity of the walker as it slows down its movement. The structure of the legs play a massive role in the walker as they are the ones that even make it walk. So that one is true as well. In studying the rigid ramp walker, we've looked deep into the physics and mechanics that make it work. We discovered how things like torque, balance, and the way forces interact.
Okay.
Right. So thank you, Pranav, for a wonderful effort which you made. Now I am coming to the first prize winner, Bhanav. Let's see his YouTube
Okay.
video.
One second. Resume the share, right?
Yes.
Okay. Bharat. Here it is.
Good morning to all. I am Bhanav from Kerala. I am going to review my INYPT second question. Let's understand the problem. By looking through a single water droplet placed on a glass surface, one can observe that the droplet acts as an imaging system. Investigate the magnification and resolution of such a lens. A water droplet placed on a plane acts like a planar convex lens because it bulges outwards due to surface tension. So it will be a magnifying lens, as you can see in this image. This is going to be the methodology to investigate this problem. First, we'll create a stable water droplet. Then, we are going to make a theoretical model predicting the properties of the droplet. After that, we test the theory. Then, we are going to construct a working microscope using this theory. After validating the results and observations, we are going to come to a conclusion. The first challenge is to create a stable droplet. A single water droplet placed on a surface quickly evaporates, changing its shape and properties. However, dropping one tiny drop of silicon oil creates a coat around the droplet, reducing evaporation and increasing the mechanical stability. We need to find the radius of curvature. This is how we do it. Consider this planar convex droplet. This is the radius of curvature of the droplet. Base radius and height of the droplet and radius of curvature of all the 5 droplets are measured and plotted in this chart. And the focal length is predicted using the lens maker's formula. The next step in this experiment to find out the actual focal length. For this, an experimental setup is made consisting of a droplet of water, an image of the letter H, and a screen, which is a paper. The water droplet is placed atop a glass slide. The distance between the droplet and image is made constant. By changing the distance between the droplet and the screen by moving the screen back and forth, a clear image of the letter H is obtained at one specific distance. The object distance and the image distance are measured. This experiment is then repeated with all 5 different droplets. Now, using the formula, one by a line diagram. Close proximity of these 2 lines indicate a high degree of accuracy in our tests. Is much lower than water. A drop of water produces more magnification compared to a drop of alcohol. Straw produces a diminished image, but a water droplet placed directly on the surface produced a magnified image. There is also one more way where we can use a straw to produce concave and convex lens. Put a coin inside a glass of water, then look at it through a straw. Now move the straw closer towards the coin. The straw will suddenly appear magnified. This is because when we move the straw towards the coin, the water surface inside the straw will have a convex meniscus, creating a convex lens. Thus, we get a magnified image. But when the straw is moved away from the coin, a diminished image of the coin is produced. This is because if the straw is moving upwards or away from the coin, a concave meniscus is formed, giving us a concave lens, giving us a diminished image. Flowers photographed up close. It's also interesting to see the mouth part and legs of a small ant through our microscope. There is one more way to create a microscope, and that is to suspend a drop of water using a syringe and then shine a very powerful laser into the droplet. Here is a picture of the algae Spirogyra. Here's a picture of some bacterium, some amoeba, and some protozoans. The water samples were taken from a nearby pond near my house. Another important feature of a lens is its be distinguished from each other. Another property of the lens is magnification. Magnification depends upon the image and object distance. Wide tunability range, wide acceptance angle, and the water surface will be extremely. Most importantly, ophthalmology. And that's because your eyeball is basically a lens made out of water. Water lenses also have huge application in space. Without gravity, we can create a much more stable lens. Here we can see NASA astronauts experimenting with fluid lenses. These experiments are the first steps towards creating a space telescope that works on a fluid lens. However, there are limitations. Low mechanical stability, vibrations which change as an imaging system is huge. Such a microscope with a magnification capability up to 30x will be highly useful as a tool in various fields.
Okay, sir.
All right, thank you. I think all the 3 winners deserve an applause for the effort which they made. And I would now like actually to invite these 3 winners one by one, and maybe very briefly tell us what was the journey and what were the lessons actually which they got through this kind of a process through which they passed. So I'll request, first of all, therefore, once again, our silver medalist, Shainika, you please tell us how did you feel participating in this tournament and what were the lessons which you learned out of it? We can stop sharing the screen now.
Is it still sharing?
Okay.
Has it stopped sharing or not?
No, you have not.
No.
No, sir, it's still sharing.
What should I do?
You will find that somewhere it is written check stop sharing.
I have done that. It says now there's a button called resume. Oh, okay. Wait a moment. Stop share.
Yes.
Found it.
Yes, sir, it is stopping.
Yeah.
Yes, Chainika, please.
First of all, sir, I'm very happy to have such an opportunity to showcase my skills in like physics experimentation. I think that the best part about this tournament was the like opposition, because you get to defend, like you get to constructively criticize other people, and obviously the entire tournament was unique by itself because it's like you don't have to visit physics labs and stuff, but you're still doing experiments at your home, like tabulating your results, trying to come to conclusions based on whatever 9th grade, 10th grade physics you know. So it was really cool participating in it. And also, like, it was also very great to see other people of your age struggling with physics problems and, you know, being able to relate with having less knowledge, but still having to apply whatever you know into whatever you have to do. And it had many challenges, but like overcoming all of them was the best part of it.
Good. Thank you. That is wonderful. I hope you will continue with this spirit of physicist. Am I right? Because now you are a physicist. I treat you as a physicist now. Because now you are not like a novice, but you are having all those ingredients which are there in the hands and minds of physicists itself. So once again, congratulations. Thank you very much.
Thank
So
you.
let me now call.
In this edition, actually, all the resources on how to conduct the research on their own was shared in the round 2 Google Classroom. The students had to learn everything by themselves by looking at the resources, videos, PDFs, and so on. So in the
Right.
next edition, we hope to make it more helpful, like more user-friendly, like add some more course-like structure to the resources.
Okay. Fine.
Can we get the link to these videos? I mean, so that we can see it leisurely.
Yes.
Right now, they are in the Google Classrooms. When we start the next version, next edition, we will again. We don't want to leave it open because then students will not have an incentive to join the tournament.
Yeah.
They just watch the resources and go away. So the students get access only when they qualify into the tournament.
No, I said I'm interested in seeing.
Oh, okay. I will add you to the classroom.
Okay.
Okay.
So let's go to Pranav now. Pranav, please come and share your experiences with us. Pranav Tyagarajan.
Good afternoon, everyone. I hope all is well. I'd like to thank the tournament organizers, the judges, and all who made this competition possible. And a very special thank you to Akshat and Nyaneshwaran sir for spending many, many hours on planning, creating hundreds of submissions, providing many resources to help the contestants along the way, little messages of appreciation and big messages filled with tips and so much more. Only those who really love what they do and have a strong dedication to their work can pull off something as majestic as this. And there are very few in the world. And there are very few people in the world just like that. Next, I'd like to thank my teachers and my uncle who have helped me throughout the course of the tournament and have brought out the best possible performance. I'd like to thank my parents who gave me a lot of emotional support and allowed me to prioritize INYPT over my board exams. A big and hearty congrats to Banav and Shainika who showed amazing performances along the way throughout this tournament.
Now, I'd like to say a couple of things that I've learned in my INYPT journey. A few years ago, my grandfather said something very powerful, which I didn't realize at the time. It was, whatever you learn will never go to waste. I learned video editing and improved my presentation skills during the quarantine days, as I used to make videos for fun. And when school started reopening again, I thought I'd never use these tools in the near future. This tournament has proved me wrong and really made me practically understand and experience the power of my grandfather's quote. I also realized that video editing can only remain as a hobby if I want to continue to love it. I used to have dreams of making a living solely by making videos, but this has brought practicality to my doorstep and made me understand something that 12-year-old me would never come to terms with. Another incredible feature of this tournament is that anyone, and I mean anyone, regardless of age, can really harness other skills to bring out their true potential with them. What I mean is an average student like me who loves, and will continue to love physics has entered this competition with very primitive knowledge about selective areas of physics and learned so much about the way the world works and truly and deeply understood that the bigger the circle of the known, the greater the contact with the unknown. I learned a lot about the behavior of objects on inclined planes, learned a bit of fluid mechanics when I was allotted the solution report on the ping pong rocket. I also learned about how sound can play a role in prediction of items and learned basics of graphing too. The whole experience was incredibly humbling, and I was really in awe of the scores the other contestants had got in the round zero, and I had just barely cleared it. I had watched many of the videos the other contestants made for their respective problems, and I was starstruck by the quality of their hard work and research. I also learned the art of patience. It took me over a month to plan, prepare, and make the presentation, make the video just for one problem from my round to submission. And most importantly, a very old demon of mine I've been running from has found me again, which is public speaking. It's one thing to be behind a screen and make videos, and another to perform with the same accuracy in front of people fixated on you. I now know that I must befriend this demon and add it to my set of tools over time. So thank you so much for this wonderful opportunity. I really enjoyed every moment of this tournament, and thank you all for making this a grand success. Thank you all.
Wonderful, Pranav. It was a pleasure listening to you and your experiences. So I think you have also given us a lesson that whenever you learn something, it is not going to go waste. Maybe you will find an opportunity later to use it. What a wonderful lesson for each one of us. Great. Thank you. So now it is the turn of Bhanav. Bhanav, please come and share your experiences with us.
Thank you, sir. Thank you very much. The INYPT competition was something unique. It was something entirely different and enjoyable. Like it was a once in a lifetime opportunity. You begin with a two-sentence problem, and that leads you entering deep into various science concepts in order to expand and then like explore the scope of the problem. Like you are finding and exploring the topic. Sometimes it felt like an investigation film, recreating the phenomenon and then making the theoretical models and then making conclusions. The competition tests both our practical and theoretical knowledge. So it's like the Oppenheimer dialogue, theory can only take you so far. The lessons we learned and the experiences we got in this tournament is certain to last a lifetime. I once again thank all the people who was included in making this tournament reality. So special thanks to Gyaneshwaran sir and Akshat for making this so much enjoyable. Like you can feel the passion these people have for physics when you do this tournament. So once again, thanking everyone who organized this. Thank you very much from the bottom of my heart. Thank you.
Pleasure is all ours, Bhanav.
Thank you.
Pranav, there is one thing which I want to ask. Three of you are now, the winners of this tournament. And when we are going to start this tournament, the way Akshat helped us, because he also had a very similar experience earlier. Would you like to be part of our mentor team for the next year? Spare some time to interact with the participants who come and who are also struggling on the way. Will it be possible for each one of you? If you think so, please just raise your hand. Yes, you are there.
It would be a pleasure, sir.
Okay, Akshat says yes. And what about Pranav?
I would love to. We will see, I
And
guess.
Chainika?
What about Chainika?
Yes, sir,
Yes,
sure.
Chainika has already raised her hand.
That's very good. That's great.
And Bhanav has also raised his hand. Good. So you are now part of our team. Thank you very much for all that. And this is how, the things move forward. And we are hoping that in future, this is how uh, uh, the people will join our journey, and we will together be able to, do something good for our Indian students who want to do physics, learn physics, and feel physics also. I think the most important part of this tournament was that you were able to feel physics in all its glory, watching nature, seeing things there, predicting something to begin with, having some hypothesis, trying to conduct an experiment, arriving at some results, analyzing them, and then concluding with your, you know, takeaways, that this is what we have taken away. Some physics, some life lessons, both together. I think that was the best part of it. Now, I think I must really move forward and start thinking uh, without whom we would not have been able to run this program. And you will ask me that who are those people whom you would like to really thank? And they are the jurors for this particular tournament. So we have the members of jury right here with us. Akshat is there, Dr. Bhardwaj Kolappa is there, Ma'am Madhurima is there, and Ganeshwaran is there definitely. Dr. Govinda, I think he must be having some work. That's why he could not really join us. So let me just tell you something very, very simple and interesting. And you will ask me, what is that simple and interesting? And that is, I'll just try to tell you who is Akshat, though I tried to tell you that. But once again, formally, let me tell you, Akshat is from Jabalpur, and he is from St. Aloysius School, Madhya Pradesh. I think I am right, Akshat? This school
Actually, the school is branched in, the school is in Jabalpur, and one of its branches is in Shahdol, where I live.
Okay.
I'm past actually.
Okay,
I'm
you
no
have
longer a student now from St.
Okay.
Aloysius.
So what are you doing, Akshat, right now?
Well, I just gave my JEE advanced. Let's
Oh,
see.
okay, waiting for the result.
Yes, and I'll probably take a gap year because I'm looking forward to apply to various other colleges as well. I'm
Okay.
really into the core sciences right now. I'm really hoping if I can gain a lot of exposure in my undergraduation in the basic sciences, the BS.
So
So
ISERS maybe your first choice.
ISERS and ISC. Let's see where I end up.
So, besides what I told you about Akshat, Akshat is very much into Hamiltonian mechanics. He says that he wants to really go deeper into it. He has started learning electrodynamics also. So he has already transitioned into a self-learner and is not waiting for his classes to and he will start learning. As you know, physics requires mathematics. Akshat is also into multivariate calculus. Calculus is in fact the cornerstone of physics. If you start from Newton and start thinking about any other set of people who followed him, the calculus was a very, very important tool in their skill set. So thank you, Akshat. Then we have
Pleasure
Dr.
is all mine.
I think, yeah, he is here only. He is definitely there. He has finished his master's in physics from IIT Madras and holds a PhD in theoretical particle physics from Michigan State University. After postdoctoral stints at Carleton University in Canada and at the University of Arizona, he joined IIT Gandhinagar, where he is now an associate professor. He works on beyond the standard model, so he's a particle physicist.
That's interesting.
of and the origin of dark matter in the universe. I think anybody who is studying in school, uh, Bhardwaj, you will agree with me that they will always have a fascination for something which happens in particle physics, astronomy, looking for dark matter and all such things. That fascination is always there.
True.
And so Bhardwaj was there to mentor all these participants. Thank you very much, Bhardwaj. Great that you helped us. I also believe in one thing, that you require not ordinary mentors for these set of participants. You require a very different kind of a mentor for whole of the program itself, because they are very inquisitive participants and they may come up with questions which may not be very easy to handle at some point of time. And they may really make you think a lot. So thank you for helping us, Dr. Bhardwaj. And I hope you are our IAPT member also. Are you there in IAPT?
No, so I should also point out that I did not do much mentoring. When Gyani asked me to serve on the panel of judges, I was more than happy. But yeah, going forward, I'll have to be more involved. Yeah, so Gyaneshwaran and I have been friends for more than 2 decades now, so I cannot say no to him. So,
But have you
it was
become
a wonderful experience.
life member of IAPT or not?
No, I am not, I think so. I'll probably register.
Okay, thank you. And thank you for being on the jury and judge and get best out of the participants in the process. Then we have, as I mentioned right in the very beginning, we have Professor Madhurima, and she is currently a professor of physics at Central University of Tamil Nadu, not Karnataka. Sorry, ma'am, I had taken it that way. It is in Thiruvarur. And she has obtained her bachelor's degree with the University from University of Madras, and both her master's and PhD from IIT Madras, followed by a postdoctoral stint at the University of Hyderabad. She is an experimental and computational soft condensed matter physicist. She takes a great interest in teaching physics, having taught students at all levels, including school. She has presented papers in physics education, is a resource person for creating teaching material for school children for the Vigyan Pratibha program for HBCSC. And in the last few years, she has been actively involved in taking science to rural school children through outreach programs. Dear friends, if you really want to feel what she does on day-to-day basis, you can visit her Facebook page also. I was very happy to see her going in the rural areas, interacting with the students. Not only that, I think she is very much into interacting with her students during teaching also. Because, you know, we who work in higher education institutions, sometimes we are happy when we work with our PhD students. But, you know, working with the undergraduate students and the PhD students, working on their projects, I was seeing that lately the convocation of the Central University was held. And in that convocation, she was talking about one of the papers which has been accepted by an MSc student for his project, which he did during his MSc. So now you can very much see that Ma'am Madhurima, how she is involved and is passionate about reaching out to people and teaching them, in mentoring them, besides her very interesting fields in which she works. Soft condensed matter physics is one very interesting field. Maybe Professor Madhurima is also using her skills of soft condensed matter physics in the kitchen as well, because our kitchen is full of soft condensed matter. So thank you, ma'am, and I hope you will be with us for the next edition of our program. I'll just also mention one thing more, that such opportunities which come our way are very rare. And sometimes, we come across them by chance, but that chance changes our life. And I'm sure that all those students who participated at different levels of this tournament, they are changed people. They are changed persons. Their worldview about things around them has changed, and they are in the true spirit of exploring nature. Because if you want to explore nature, you need to ask questions. So ultimately, what do we do in physics? We keep on asking questions and questions, and so we really go ahead. So thank you, ma'am, once again. And now I'm also going to tell you about Dr. Govinda, who is not here, but I think you must know what he does. He is a very passionate person and is teaching in Bajaj College of Sciences, Wardha. And, he has a wonderful background of interacting with students at the school level, particularly. He was director of the Bajaj Science Center at Wardha in his college. And he, in fact, curated that center and has run very many interesting programs there, online as well as offline. And he loves doing things offline. He's also part of our NICE program, which is Nani and Vishika Experimental Skill Test, which is actually right now going on. So he is a very active participant in that. So this is what is about Professor Govinda. And lately, in Nagpur, he has started participating in a very interesting other project called Exploratory. That Exploratory has been established as a dedicated center for school and college students who can come there and conduct experiments, meet experts also. So that is how we are going ahead with it. And finally, with the person who provided leadership to this program, Ganeshwaran. I think he is a passionate teacher, and he is into the physics problems very deeply. I wish if I could have been like him, the way he actually starts thinking. And also, he will suddenly go into a mode of conducting an experiment, a thought of which may have come to his mind during teaching in the classroom itself. And he is basically looking for young talent, and that is how he found Akshat, and try to see that now they have a kind of a bonding also. This is how you start coming across certain people who are like you, who feel like working with you. And Ganeshwaran is an asset to his school, which is a very famous school. He teaches in Doon School. Whenever we hear about Doon School, or whenever we hear about Doon, there are two names which come to mind. One is the Doon School, and other is the Ruskin Bond, because he has done a lot of his stories around Dehradun also. Maybe you might have read some stories about him. So I think we are very much near the end. May I request Dr. Bharadwaj to please switch on your camera, and Dr. Kuldeep. Dr. Kuldeep is from NIT Hamirpur.
Namaskar, sir.
Namaste. We are not able to see your picture. Light नहीं है या तो?
Maybe.
Yeah, now we can see. Yes. Yeah.
Okay, sir.
Thank you.
Namaskar,
So
sir. Sabko namaskar.
Namaskar. We are ready. Pranav, please switch on your camera. Yes, we are ready for the group photograph for this particular function. So, Ganeshwaran, are you going to take the picture? You are muted.
Yeah, sure. I would request the winners to lift their medals.
Yes,
Please.
please raise your medal and the trophy. Yes, yes, yes. Pranav, yes, very good.
Oh, and the smile is
Congratulations to
imperative,
all.
please.
Yeah, I've taken.
Thank you. So we are at the end of the program, and I was given.
Congratulations once again to all of you and best wishes for future endeavor. बहुत अच्छा प्रोग्राम रहा सर.
हम
Thank you,
एक
sir.
एक मिनट के लिए मैम मधुरिमा से बोलेंगे कि प्लीज टेल अस योर एक्सपीरियंस इन 1 or 2 minutes, मैम, if possible. Switch, yeah.
Good evening, all of you. It's a pleasure to be a part of this particular program. And first of all, hearty congratulations to Pranav, Shayanika, and Bhana. I think your performance has been really inspiring because at school level, the kind of clarity that you have displayed in explaining physics concepts is really commendable. I was watching you from the penultimate round onwards, and not just the three of them. I think all the participants had done a very, very good job. In fact, all of you are winners in your own way. And like Pranav was mentioning, there are so many skills that you pick up on the sidelines, which will go a really long way with you. I mean, I wish I could do video editing with the same expertise that all of you did. So hearty congratulations. This has been a really interesting experience. And on a personal note, I'm very happy to be a part of this particular program for two reasons. The obvious one being that the trophy is named after our father, and he would have been happy to see young experimentalists, being an experimentalist himself. The other one is I work in the field of liquid drops. So to see Bhanav's experiments was a different kind of pleasure because that's the kind of work that I do. And kudos to all of you. And I should thank IAPT in general and Jnani and Professor Auliwalia in particular for giving me this opportunity and giving us a chance to be a part of this, the first initiative of its kind. Thank you very much.
Thank you. And now I would like to request Dr. Bharadwaj, please share your thoughts.
So this has been the first time I've been part of an IAPT endeavor, and I should say it was eye-opening on many fronts. So I have tried teaching labs during my PhD days, and I have sort of been involved during the initial stages of our MSc lab also, though I'm not an experimentalist. Most experiments at the MSc level in physics tend to be like black box kind of experiments. So they give you an equipment and they tell you what to do, and the MSc students do it. And then they tell you if the answer is not accurate, some predetermined error analysis calculations. This was very different. This is the kind of experimentation I would have loved to do when I was a high school student, because you guys build something from scratch. You identified a problem, build something from scratch, and then try to understand if it was not going well, understand why it was not going well. This is the true spirit of experimentation, and this is the kind of things that you would end up doing if you were to do a research project in physics at any level. So kudos to all of you, and I personally learned quite a bit, and I really like the format of the jury and the arbiter kind of rounds too. That is something that I plan to sneak up on my students as well, because I think it's a very cute way of understanding and debating science, which was how it was originally done in the past centuries. So yeah, a lot of take-home points for me, and it was a pleasure and an honor to be part of this experience. And I know Gyaneshwaran, is a passionate teacher, a passionate learner. He was the one who used to ask most questions when we were in BSc and MSc together, and made teachers' lives very uncomfortable. While most of us just accepted things and went on, he was never satisfied. So I knew he was going to end up, brightening the lives of many other young people, and I'm happy to see it happen. So thanks to everybody.
Thank you. And now, yes.
Yeah, thank you, Bharadwaj. And So,
Very briefly.
what is your opinion about the online physics fight where you had to sit judging for almost 5 hours, 4 hours?
Sorry, can you repeat the question?
Your judging work, it lasted almost 4 hours, right? The grand finale. Was
So,
it
4.5.
Initially, I had no idea it was going to last that long. And while it was going on, I never had a problem with it because I was enjoying the process so much. So if you had gotten any complaints of that sort, I don't know, but I personally had no issues with it. It was a pleasure. But I don't know from the students' perspective how, because, because we are not doing the actual thinking, so to speak, because they are the ones who are actually, they have to be involved at every stage. So it might be a little mentally tiring for the student. But from a judging perspective, it was a very enjoyable actually. So, but yeah, for a student, it might have been a little tiring. Not sure.
Okay.
So Akshat, when you are on the other side of the table, how did you feel about it now? Tell us that.
Actually, I feel deeply honored. I'm very honored actually to have been part of the jury this time. It was so enjoyable, and I could literally, especially when Pranav was reporting, when Chayanika was reporting, when Bhanav was reporting, I could just recall the time when I once did it for the very first time and how frightened I was and how thrilling it was for me. I was just trying to recall it, and I was just having a good time reviewing them and just looking at the shine in their eyes while they were just explaining their stuff very precisely and very elaboratively, and it was really fun doing that. I know I was not a very good part of the jury, and for
Why?
a good reason, I think.
Why do you say that? No, actually, for the preliminary rounds, we had we had to watch around more than 150 videos, and in each round the videos are like 10 minutes long, 5 minutes long, 12 minutes long. Some videos are 20 minutes long.
But
So
we did
I
go through all of
personally
them.
watched every single video, and Akshat also watched every single video, and we both discussed which are supposed to be the better ones, and we scored so that we ensured perfect scoring. So he did a very good job helping me out with the judging of all the videos.
Pleasure was all mine at the end of the day, and I really had a good time with this tournament. And I still remember when I and Mr. Ganeshwaran had been discussing about something like this to be proposed to IAPT, and something like this to be brought up and executed all throughout India, because we saw the presentations from countries like Singapore and Germany, and they were really proposing and reporting their work in such a well-framed manner, and the rigor they had. I and Mr. Ganeshwaran were so much fascinated by that, and we really thought it's how interesting it would be to see Indian students, especially us students, doing the same thing and progressing further, learning and presenting the work, basically. Doing all that, I really enjoyed it, and I had a good time, basically. Thank you very much for listening to me, and thank you very much for making me be part of it.
Thank you. Well, thank you, Professor Madhurima. If you want to leave, you can please. Thank you for sparing so much time for us. Thanks.
Thank you and bye. Yeah.
Thank you.
Now I wish to come to Ganeshwaran also. Ganeshwaran, how did you find this tournament? Tell us that also.
Yeah. So I feel that it achieved the main goal, the mission which I had, which is to spot young talent and create curiosity in the young minds and nurture the curiosity of the children, and don't let it die with age. Usually I find that as children grow older, the curiosity also dies. So I wanted them to get into the habit of questioning what they see. First of all, see what is happening around them. So for example, my son who is in grade 5, he saw in his bracelet kada, the shape formed, which was in the shape of a cardioid. So he only told me that there is a butt in my kada. So I was shocked, what is this butt in a kada? Then I saw that the shape of the shadow was in the shape of a heart, and it has a name cardioid. But from his perspective, it appeared like a butt, which is also not entirely wrong. So then I researched into it, and it turns out that it's due to reflection from a circular surface, which is being illuminated by a plain light source from one side. So it's very interesting. So all the problems of INYPT are also like this, based on real life. So I want the students to get into the habit of doing research, applying scientific method. And so that's why I made it online and free entry, free registration, so that we want to reach the whole India. Every student should benefit from it. And we did it. And this year I expect it to be even bigger. And one more interesting thing is, this tournament is for school students. We have a similar tournament called Indian Physics Tournament.
Yes.
It is for college students.
Hmm.
So India already has INYPT already has the rights to select the Team India, or actually the role of selecting Team India. So we'll conduct both the tournaments parallelly, and we're planning to have some integration also, collaboration also. So we can have the college students interacting with the school students. And I think the science will spread exponentially with more business interaction. So from June 15th, we are starting the new edition, second edition of INYPT, and we'll parallelly start IPT also.
Okay, so that is great. Thank you, Ganeshwaran. But for you, this tournament would not have been possible, because there is always an anchor who is needed, and you played that role fantastically, I must say. And on behalf of Indian Association of Physics Teachers, and on my personal behalf, I thank you very much for initiating such a fascinating program for not only INYPT, but for the school students of India. And I'm sure slowly and steadily people will realize that this is a program which should be owned and should lead to the participation of Indian team in international young physics tournament. And I think we will keep on trying that. And let us see how that really emerges. But at least INYPT has got a fantastic competition, very different from routine kind of examinations. We have Ganeshwaran ma'am Sarmishta also. She is a very, very experienced experimentalist. She has won very many prizes in INYPT innovative experiments in physics. Though she is retired, but she is not tired, and she is still doing this. In the last edition of our convention, she again won a prize for her innovative experiment in physics. So, ma'am, I would like to know from you after this interaction, how did you find this particular tournament?
I'm really impressed and awed by looking at the children, such wonderful work they can do starting from scratch. So now that they have already shown their capabilities, I'm wondering whether they are aware of the National Anveshika Experimental Skill Test. Have you all heard of this,
Yes, ma'am.
children? You all have.
Yes, ma'am.
Have you participated?
Yes, ma'am. I went for I participated in 9th grade and I made it till the finals.
Very
And
good.
last year I could only do till the prelims. One of my friends participated.
Acha, now, which class are you in right now?
I have just finished my 10th board exams.
So you can still participate in 11th and 12th.
Yeah, I have registered for this time, this
This
year's
time. Okay.
IEST.
What about the other two? Are you all aware of it? Bhanav? Pranav?
Yes, ma'am. Yes, ma'am. I heard the name.
You heard the name. I said, since you have not joined this time, the exams have already started. You can't do it now. But at least for the next year, keep yourself aware. And when the registration is going on, please do participate. You will get similar experience and you can actually add on. So don't leave this practice of doing experiments all by yourself. Should keep it going and probably create something new for every year and come up with a wonderful discovery and go ahead and get the Nobel Prize later. Wonderful.
Thank you, ma'am. Thank you, ma'am.
It's an excellent work. I had heard Akshat before. He's, as usual, very dynamic and he's taking a lot of care of the coming students. I'm really grateful to him. So please continue your work, even if you have joined some ISER or somewhere else. That will help the students in the future. So this is a program which is being done by the Indian students alone. Am I aware? I was not very clear. So the prizes are for the competitions, but how do they join the international thing?
Actually, for joining the international IYPT tournament,
Hmm.
the government of India has
Hmm.
not involved actually. The IYPT tournament itself appoints one
Hmm.
person as the IYPT organizing committee and IYPT member organization. So already the very first person who showed interest in this tournament, he collected his team of students, some 5 students, and they spent around 2 lakhs each to pay for their travel expense, tournament fee, everything by themselves. And they attended the tournament only as an observer. So that is the first condition to become an IOC, that is IOPT organizing committee or IOPT member organization. So after meeting this criteria, the head teacher of the school, he became the IMO and IOC of India, and he has been continuing ever since. And his job is to select Team India, top 5 students.
Okay.
But he is supposed to conduct a proper tournament and select students from whole India. But his first criteria for selection is, can you spend 2 lakhs? That is the first criteria. So all the students who can't pay 2 lakhs, they drop away. Then he just conducts 2 rounds where the students are given one problem each in the second round. First round, the students submit the report of the one problem. And so students really don't learn anything much, and they're not given any help or scaffolding or training. So the 5 students who are the best, who have applied to him from the website by themselves, they go with him, they pay for him, and they attend the tournament. And India usually stand in the bottom 3 positions. If 25
That's very
teams are there,
unfortunate.
if 25 teams are there, India is the 19th or 18th. It's a story all the case from when India started participating. So that's why I broke out of them, and I tried to contact IYPT, but they are saying that we have our rules. So their rules are rigid. So either the current IOC has to appoint a new IOC, or the new person who is interested has to spend his own money, around 5 lakhs, and visit the tournament. So it's not worth. So that's why we came up with the idea that if our goal is to develop science and technology research skills in Indian students, let's conduct it at the Indian level.
Indian.
The 13 programs which they release each year, the tournament organizers, IVPT has left it open for use by anybody. So nobody can use those programs to conduct a tournament. So that's not a problem. So we are just giving away the prizes at the Indian level itself and wrapping it up here. So if those who want to go to IIPT, they have to go through the current IOC.
No, but these children who have won now, are they
Yeah.
eligible for going for the international competition?
No, they are not eligible. They have to go through the IOC, who is actually Shrikant Pandey. So they have to go through him, and he has his own process of selection.
It is very unfortunate that
Yes.
people at international young physicists tournament level are very rigid, and some of the other, I mean, even when they are science people, they are not very objective in deciding about how people or how competitors come from different countries. I mean, we have tried to tell them that we are a credible organization working at the all India level, but they didn't listen to that. So I think better it is that instead of waiting for them, we thought that we should start this right at the level of India itself, because
That's
that are also very many lessons which we can share with our students via this medium itself.
right, right.
That is how we looked at it. So thank you, Ma'am Sharmishta. Thank you for joining. And now I will request Dr. Kuldeep, actually, who is head of the physics department at NIT Hamirpur. And he is also president of Regional Council Himachal Pradesh. So he is
Namaskar, sir.
the host for your convention of the Nani. I
Nani.
hope you know that. So Kuldeepji, please
I'm coming.
briefly tell us, how did you find this 1.5 hours? Rather, yes, it's 1.5 hours. So please tell us, how was the experience?
First of all, I would like to congratulate the winners of this tournament and wish all the best for their future endeavors. And it was my first meeting to attend this program, and I feel honored by attending this meeting and interacting with these young students, and especially I congratulate to Ganeshwaran and Sarmishta ma'am and Bharadwaj sir for making this, and other all mentors and jury members for making this possible, and for their efforts. Because any tournament, if you want to organize it properly, and it requires a lot of efforts, and I can see how much efforts all of them they put in while organizing this tournament. And this is a very good platform to showcase the talent by young students, and share their thoughts through performing practicals. And unfortunately, this part is missing in today's engineering student. I see, though they are known technology students, but they don't have much knowledge, experimental knowledge about this. And it is very good to see that the students are showing their interest, and they are working on very interesting problems, and shown the results also. So it is very good to promote physics among the young students, and they are the future of our country. And I hope this practice will definitely raise the level of our understanding and demonstrating the physics throughout the country. And that's all from my side. Thank you, sir, for giving me this opportunity to attend this meeting. Thank you, sir. Thank you all.
Being with us for the whole of the time. Now I will request Ganeshwaran, please tell us when are we going to start the next edition, and what is the plan for that?
June 15th. So June 15th, with the registration will be starting also for IPT as well as INYPT, and the websites will be on from June 15th. So all the information will be passed on. So we are planning same format, similar rounds, but some collaboration added between the two tournaments.
Okay, so this INPT and INYPT,
yes,
together. So just for the benefit of the participants here, that INPT is for undergraduate students and university students. And the last version which we had, in that basically the trigger came from IISc Bengaluru to start that program. Hopefully these things will pick up. We are at a very, very nascent stage in both the tournaments, but I think they will become once again the flagship programs of IAPT. I am very sure about that. So in the end, I think it was my pleasure to be with you and act as a host also of this particular program, the duty which was entrusted to me. And I think I enjoyed it. Though I have not been into the nitty-gritties of this tournament too much because of my other engagements. I wish if I had more time, I would have definitely been pursuing this particular competition with Ganeshwaran. And once again, hats off to Ganeshwaran for your love for physics, for your inquisitiveness, and the way you work. I'm sure you have brought good spirit to a very different kind of a way to become a physicist, I would say, because it is not just one short program that you do one experiment. It engages you for whole of the year, and that engagement itself is very important. What is the end result? That's not very important. The engagement is very important. So once again, let me say thank you very much to each one of you. Chainika, looking forward to see you again and again in some one way or the other. Maybe we will see you doing masters and then PhD in physics. I think you three of you are very articulate. I'm really impressed by your communication skills. Pranav, yours was, like a motivational lecture for us also, the way you spoke. I hope each one of you will agree with me.
Yeah.
And
Yes.
Bhanav, I had even been interacting with Bhanav otherwise also. How I came in contact with him and how I think his father is also very passionate about all these things. Well done. And see you again sometimes at some point of time. And also as mentors in the next year's edition of Indian Young Physicists Tournament. Thank you very much to all.
Thank you, sir.
Thank you.
So we can leave now, right?
Yes.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you so much.